there's one of those numbers, and there's 6 numbers, only one of those 6 also includes B. So six possible outcomes with A, only one of those also is B. So it's 1 in 6. Again, if we were to use the formula, we'd say, what's the probability of the intersection, which is a 16th, so probability that both occurring, over the probability of just A occurring, which is 1 on 6, which again, if you put this into your calculator, would give you 1 over, if you put a 16th over a 6, it gives you 1 on, and you can see it there, it's 1 on 6. Okay, again, 2 ways of doing that. You can look at it hopefully and see it intuitively, but also if you can't, the formula should be your go-to thing. This one here.
Wait, where's that bottom 1 on 6 come from?
Because
it's not 1 on 6.
Sorry, it's not 1 on 6. Sorry, it's not 1 on 6 at all. Sorry, that's a good question. It's not, it's 6 on 16. Sorry, because there's 6 ways that A can occur. Sorry, it's 6 on 16. Because there's 6 ways that A can occur out of 16. So remember, it's the probability of A and B both occurring, which is 1 on 16, over the probability of just A occurring, which is there's 6 ways that can happen, isn't there? So it's 6 on 16. So that should give you the 1 on 6. Any questions about that?
Wait, of just A, isn't just A 5?
No, of A occurring in general. Like, it's not saying just A, it's like what's the probability of A occurring?
Yeah, okay.
So it's the probability of A and B both occurring over the probability of A occurring.
Yeah. Wait, what are you actually finding? For B?
What we're finding here, so what this gives us is the probability.
The answer, Meg.
So it's the probability of B occurring. So of us rolling a multiple of 4, given we know the number is less than 7. So given we know the number is...
It's only 1 in 16 then.
It's 1 in 6. There's 6 ways you can get a number less than 7.
How?
Because it's only 1, 2, 3, 4, 5 or 6. And out of those 6 ways, there's one in which is also fitting event B, which is just the 4, isn't it? Okay, ready? Thanks. Okay, guys, we'll go through this last one. So this question sort of asked in a slightly different way, but it's the same idea. In an electorate, we have 55 voters. 55. So in an electorate, there's 55% of voters are female. So let's imagine like this electorate here. 55% of the voters are female. So that means what percent are female? So what percent are male?
Would that be 55%?
45. So that's
Sexist.
60% of male supporters support the Labor, but only 45% of female supporters support Labor. So that's sort of a breakdown. First bit is we want to show this information on a tree diagram. So what do you think would be our first branch on this tree diagram?
Females and males.
Yep, so we break this down to females. So you have females and males. And what's the probability that a person is a 50? So the probability that someone is a female is 55% or point. Guys, again, can we please not interrupt things? So the probability of female is 55% or 0.45. Male is 0.45.
Yep.
Now, that's the first branch. There's actually 4 possible outcomes people can fit into here, isn't there? What's the second branch gonna be? Let's start with the females. So support and or not support. Let's just do an and or you can use any letter there. Support or not support. What's the probability that a female so let's look at this branch here. What's the probability that a female supports the Labor Party? 45% or 0.45. What's the probability that a female doesn't support the Labor Party? What is 50.55. Males, what's the probability of support and not support? There's 0.6 and 0.4. So there's those 4 possible outcomes of things that can happen, isn't there? We can have a female supports the Labor Party, female that doesn't support it. Then that's the 4 branches of things that can happen. What we need to do now is to work out each of the individual probabilities, each of those 4 things occurring. So if you pick a person at random from this electorate, what's the probability that they fit into each of those 4 categories? They're not even, are they? So can someone get the calculators out for me? Who's got one in front of them?
I didn't bring mine.
That's right, Iggy. We've already got you busy, that's fine. Okay, so we multiply. Remember to go along these branches, you multiply the probabilities together. So can you just do for me 0.2475. What's this one here? So 0.55 times 0.55.
3025.
3025. This one. So 0.45 times 0.6. 0.27. Is that? Can you go to 4 decimal places? Just so it's the same. So can you just tell me what it is to 4 decimal places?
2700.
Okay, right. Yeah. Okay, and the last one. 0.45 times 0.4. 0.18. Okay, guys, what this is saying. Okay, I just want to be really clear here. What this is saying is we've got 4. So we've got electorate. Obviously, electorate has there's males and females. That's pretty obvious. We're breaking it down into people that support the Labor Party or people that don't. So we could have a female that supports the Labor Party, and the probability of that occurring is this. A female that doesn't support the Labor Party, this is the probability. A male that supports the Labor Party is this probability. A male that doesn't support the Labor Party is this. What do we know? And this is again is a check we can do with these types of things. So this is actually not. This is what the same sort of thing we did in the last class. This is not. This shouldn't be necessarily a new thing. What happens if we were to add all those things together?
Equal 1.
They should have to equal 1. We've rounded, so they won't be exactly 1, but they should if we took rounding out of the equation.
No, we didn't round because.
Oh, we didn't? Okay. Then they should actually equal 1. So that's the thing. That's a bit of a check we can do. Because everybody you pick in this lecture has to fit in one of those 4 categories, doesn't it? If they didn't, it doesn't really make any sense. They have to be one of those. So we've done that before. Last time we had questions like what's the probability of picking a female that doesn't support the Labor Party would be that one. We've done that already. What we're looking at now is using this. And if you want to go back to this formula, using this formula to answer some questions about like given statements. So if we look at this up here, it says down here it says find the probability that a person selected from the electorate is a male, given we already know that they're a Labor supporter. So given we know the person, so we've taken a person from this electorate, a random person, and all we know about that person is that they're a Labor supporter. We don't know at this stage whether they're male or female. We don't know what the probability of that person being a male is. This one doesn't really have, unlike the other 2 we've done, this one doesn't really have any shortcut way of doing it besides using this formula here. That's the only way we could do it. So we would have to say, what's the probability of, so let's even rewrite down this formula. So it's equal to the probability of A and B. So in this case, not A and B, it's given, so it's probability of male and Labor supporter, so male and supporter, over the probability of just the one that's the given one. So it's A given B, so just the one that's the given one, which the given one is just a supporter. So what's the probability of being a male and a supporter over the probability of just being a supporter? So from this up here, what is the probability of us picking out of the crowd of people a male who is also a supporter of the Labor Party? 0.27, can we see that? So it's 0.27. What's the probability of us picking a person out of the crowd randomly who is just, regardless of male or female, is a supporter of Labor?
0.5175.
Yeah, so it's these 2 added together, isn't it? Can we see that? They can be a female supporter or a male supporter. So it's this here, 0.2. We'll break this down. 0.2475 plus 0.4275 plus 0.27. So probability of just being of the intersection. So probability of them being a male and a supporter over the probability of them being just a supporter of the Labor Party, which is this plus this. And what does that give us in total?
0.521.
0.521. So the probability,
12 out of 23.
yeah. So the probability is about 52.1%. So that's what it means. So even though, thanks guys. So even though we know that, this isn't given to us here, we know that if we had, for example, another way of thinking about this too is if we know if we were to run like some sort of like Labor convention thing, we know that 52% of those people would be a male, even though there's less males in. So even though there's less males in the electorate, there's more males in as Labor supporters, the high percentage of males in the Labor supporters. So that's the kind of thing we can work out. Yep.
Do we answer it as a fraction or?
It doesn't matter. Yeah. I think percentages tend to be better because they're kind of how we tend to work with it. But it doesn't really. Like, probability can be expressed as fractions, percentages, or decimals. They're not. It doesn't really matter.
They're all the same.
They're all the same thing anyway. So unless you're specifically told what is it as the percent, or what the question might say, what percent of supporters are male given their Labor supporters or something. We might actually ask you what to put as, but if it doesn't ask you, it doesn't matter. Okay, guys, before Eddie turns off this camera, any questions about that? Right.
I'm interested to see that.
Okay, thanks. Okay, I might. If we can turn off Eddie, thanks.
Bye.
Say bye, Meg.